Wow, well, if there was any way to move this outside, I would move this outside, right? I feel like it's such a poor, alternative to the views out here, but we'll have a good conversation anyway. Then we'll go check out the views later on. So anyway, welcome to this afternoon's session on building reactive pipelines, or how to go from scalable apps to ridiculously scalable systems. I am Mark Heckler, and that's the best way to reach me. I'll get into more like who I am and all that stuff in a moment. But who here has had their boss come to them and say, hey, look, you did a great job last year. I'm going to double your budget, and could you slow down a little bit? You're making us look too good. Never, right? And if you, by the way, if you are in that situation, please do let me know. I mean, I would love to add this to my super few case studies on, crazy, productive, and employee-loving organizations. But typically, we're asked to do more with less, or at the very best case, more with the same, right? It just never happens that we are not, in some way, looking for a way to do more, to get more, extract more performance, scalability, what have you, out of the current resources that we have, which is kind of why we're here, right? This is really kind of a different format for me, because I'm used to having the situation where I have a lot of information I want to try to cover really super fast, and I tend to get excited and talk faster anyway. But here in beautiful Banff, we have an hour, which is great. I also have a few extra things I want to slip in, so I'm kind of balancing between I want to slow down just a little and relax, which will be great, but I also don't want to slow down and relax that I still can't cover more than I usually do in a shorter amount of time. But some of the things that we'll be talking about today are traditional approaches to scaling systems and how far those can take you. Typically things that we employ on a daily basis or want to and working toward employing. And then when we do that, and we do all the things that are the normal check this box, check that box, that may be enough. That may be sufficient. If so, you're done. That's great. Take a couple weeks off. But if you are wildly successful, if you have an application or a series of applications that are wildly successful, and you suddenly hit a wall with those, what happens next? What are the things that we can do to reach beyond the limits when we hit them initially? And then all of this sounds good. I like talking theory, but I really like seeing it in action and understanding how it all works when you put it into action. For me, the magic's in the code, right? That's where you see what happens when you try to employ some of the techniques. So we'll get into code, and we'll do some live coding today. A couple things. We'll be discussing a couple of lines of thought today, at least. Notice I didn't say threads. But we'll be discussing a couple of, parallel kind of working together lines of thought. We'll tie them together toward the end, weave them together, hopefully. And I would ask that you hold your questions until the end, and we'll kind of go through things, and then whatever time is left, I'm perfectly happy to talk at length. Or if you think of something 10 minutes after you walk out, like I always do, ping me on Twitter, email, what have you. So with that, quick introduction, who am I? I've authored several blogs and blog posts. I've co-authored a couple of books. I have contributed content and code to several other books, a few of which even recognize my contributions. That was nice. The rest of them, I never recommend those. They're terrible people. I'm kidding, they're not. But it's always nice to be recognized for your work, right? And I do have another book project that I am starting in the beginning of next year. So if you want to know more, hear more about that, the best way is where I live most of my life, and that's on Twitter. And I'll show you the coordinates of that later again, but it's just mkheck. So follow me on Twitter for all the latest, greatest announcements and fun banter. I won't say witty, but certainly I try to have a good time. I am an architect and developer, and as you might surmise from the next point, where most of my expertise has been won, it's been in the Java ecosystem, so some Groovy, some Java, some Kotlin, well, okay, a lot of Java, fair amount of Kotlin of late, the last couple of 3 years. And again, Java Champion, Java 1 Rockstar, Code 1 Rockstar, Groundbreaker Ambassador, a handful of other awards and honors that I'm really grateful for. However, I still have to pay for my own coffee, so I don't know. I guess that tells you what they're worth. I am a professional problem solver, not officially, just unofficially, as are you, or you wouldn't be here, right? Spending your Saturday, although the location could be worse. I am a Spring developer and advocate, officially. I work on the Spring team, commit code, get to travel and talk about it. So it's kind of, for me, my ideal job after my wife. I love two things in this world, coding and talking. So if I can code and talk about code, it's even better. I am the sole creator and curator of Spring Noticias en Español. So if you are a Spanish speaker, if you produce videos, blog posts, whatever, let me amplify your voice. Let me help spread your message to the community and boost the community as well, right? The more we all share, the more we all learn. If not, that's cool too. Okay, so how do we get started? Typically when you think about scaling systems, let's start with the monolith, right? Most of us have dealt or are dealing with a monolith. And I should stop for a moment and say, I've given this talk a couple or 3 times before, and I was never super happy with the way I covered, I think, a lot of things, and I got good feedback, but I was never super happy with the way it all came together, right? I felt like it kind of covered a topic, and I didn't feel like I tied them together like I wanted to. So the beginning of this week, I refactored the whole talk. So I have some material from before. I've added another material. I've shifted it. I've expanded on some stuff. I've de-emphasized or eliminated other. So I'm trying this out. This is the second time in this week that I've actually trotted this talk out and kind of trying it out. So I would value your feedback. If you feel like, hey, I didn't quite understand what you were saying when you got to here, let me know, please, because it's a matter of refinement, right? So let's start with the monolith. Most of us have worked or are working with a monolith. The thing about monoliths is that they don't scale really well. Why is that? Because a monolith itself is composed of numerous different capabilities. And if a monolith has, let's say, 10 capabilities, there will be 1 or 2 that are just used extensively, just hammered all the time. And then there'll be 2, 3, 5 that are hardly used at all, right? And then you'll have others that are in the middle that are occasionally used somewhat, but certainly much less than the high performers. When you need to scale those capabilities that are being hammered, what do you have to do with a monolith? You have to scale the entire monolith, right? So you pick up and duplicate. And setting aside contention issues and things like that, when you have 2 instances, when you initially intended 1, only built and architected for 1, it certainly isn't an efficient way to scale, right? For the bits of capability you need to scale out dramatically, you're bringing along a lot of extra baggage with those. So it makes sense in many cases to start exploring microservices, to start teasing out those bits of functionality that are very dynamic, that are crazy scalable, have crazy scaling requirements. So that's where most people's microservices journey starts. Unless you hear a talk, you get really excited and you want to go, do resume-driven development. But in generally speaking, I mean, we are kind of a shiny object-driven breed, I guess. But generally speaking, we're problem solvers. We look for problems, and when we see them and we see a solution to that, we start exploring, right? So if we tease out those bits of functionality and we create microservices and split those up from the monolith, we have faster development velocity because we don't have to update, test, deploy everything together. We update, test, and deploy the things that matter, that change very quickly. We also are able to scale those out and in very quickly, very easily when you have just those core bits of very, very heavily used functionality that you're scaling versus everything at once. So that's a really good start, right? And then when we kind of get to that point, we start looking at other things. How can we scale even further? So a lot of times we start looking at messaging platforms, because when we tease out the bits of functionality in microservices, what we find is that we're still coupled in some ways to other functionality. If you have 1 or 2 or 5 microservices that need to communicate among themselves to accomplish a particular task, you're going to be scaling those somewhat together, right? And when it comes to communication, I like to take an example and distill it to the simplest example and then build it out. So we'll do that now in this case. So if you have a couple of microservices and you need to, service A needs to talk to service B and they need to interact in order to accomplish a task. That means if you need to scale the number of requests for a particular microservice, and at some point you're going to hit the wall and you create another instance of that service A, you're probably going to be scaling service B roughly linearly, right? Because you're going to have requests and responses between the two. Most cases, and I do tend to start off again, because most of the time you go to a microservices architecture, you're dealing with an HTTP-based API. And that works okay, again, but you notice they're coupled. So if one goes offline, what happens? If you have a network problem, what happens? So there are a lot of things that potential breakages or limits to scalability that you run into. Thus, messaging platforms. Messaging platforms allow you to divorce the two, or multiples, temporally and locationally. because I can drop a message into a queue and walk away as a producer of said message. The consumer of said message may not even be online when I produce that message. It may come online minutes or hours later, and when it comes online, I may be offline. That's fine. It's temporarily, decoupled. It's also locationally decoupled because the consumer of said message doesn't necessarily need to know or care where that message came from. It just says, oh, I have a message, I need to consume it, and thus it does. So messaging platforms give you, quite a bit more flexibility as well. Messaging platforms, too, are typically a part of your critical infrastructure, which means that your critical infrastructure team or your cloud provider makes sure that they're online and accessible at all times. If your messaging platform is offline, typically it means you have bigger problems than your messaging platform being offline. It means everything's offline, right? So it gives you certain things like delivery guarantees, retention guarantees, things like that, that are baked into the messaging platform itself in one way or another, depending on your messaging platform. I have a few notes to make sure I don't blithely skip over anything, or at least fewer things. So several messaging platforms exist, right? I like to distill it to the top 5 in my mind. So you have RabbitMQ and Kafka, both of which are widely deployed, widely proven, have great scalability, have different strengths from each other, but they're well recognized as being kind of leaders in their peer group. And then you have various different entries from several other offerings as well. But from the big 3 cloud providers, you have various different offerings, even within each cloud provider. I like to kind of bubble those up to the top one of each. So you have Microsoft or Azure Event Hubs, and Amazon Kinesis, and Google's Cloud Pub Sub. And again, they all have other offerings as well. I just kind of consider these the top 3, one from each. Don't know if you care, but none of those are open source, except for the first 2, which are RabbitMQ and Kafka. Maybe that's a big deal to you, maybe it's not a deal at all, but it's something to keep in mind as well. RabbitMQ and Kafka I typically look at as the first among those peers because they can be run anywhere. You can run them on your laptop in Docker, you can run them on a server in your own private cloud. The companies who largely shepherd them and guide them through their development will host them. You can have third-party hosts. You can run them on the big 3. So you have various different options with those that you may not necessarily have, like Azure Event Hubs only runs on Microsoft Cloud, right? Kind of makes sense. Okay, so let's see. Occasionally it does make sense to pick one, to standardize on one. But even if you do, let's say your company is standardized on Kafka and you acquire a company that's standardized on RabbitMQ, now what? Now you're back in the I'm supporting multiple platforms game, right? So as a developer, we always tend to look for a way to stay at the highest level of abstraction for maximum productivity. We also, though, don't want to give up access to the knobs and levers underneath in case we need to adjust things, right? There is a way to do that, and that's Spring Cloud Stream. Spring Cloud Stream is 100% open source as well. All development's done out in the open. It's on GitHub. Project pages are open as well for everybody to peruse. You're welcome to submit PRs. Again, I always tell people if you see something that's missing or that doesn't work like you think, it should ask first in case you're just misunderstanding, or maybe there's something that is in the works already so you don't waste time. But if there's a bit of functionality that's missing or something you want to add and it's not being worked, contribution's welcome, right? It's an open source project. The wonderful thing about Spring Cloud Stream is it uses binders to deal with all of the different messaging platforms. So it allows you to stay at that higher level of abstraction, be very productive, and use Rabbit, use Kafka, use Kinesis, what have you. And switch between them should the need arise. I have another talk that I show how easy it is to switch between them. Don't think we're going to have time for that today because I'm wanting to focus on other things, but certainly it takes a lot of pressure off you if you are in one of those environments that has a bad habit of dynamically changing with no notice. Oh, wow, okay. That's crazy groupies. Kidding. So among the binders, right, you typically will have a binder for each messaging platform, some of which we maintain within the Spring team, so things like Rabbit, Kafka, Kinesis, we maintain. We have partner-maintained binders for Azure Event Hubs, Google's Cloud Pub Sub, and by partner I mean each respective company maintains them. Microsoft maintains the Event Hubs binder, Google maintains the Cloud Pub Sub binder. And then you have community binders, so if you see something that's like, well, that's not any of those 5 and I need to deal with them, there's probably a binder out there. Maybe it's up to date. Maybe somebody hasn't worked on it in 6 months or a year, but certainly there are a ton of binders out there that help, again, give you a great starting point. So I think that's all the high points there, and I'm getting excessively dry, so I'm going to have to take a drink here. Oh, so nice. Okay, so again, kind of boiling it down to a very simple example. This is kind of an example of what Spring Cloud Stream provides, and again, we'll build up from here. But built into Spring Cloud Stream, you have 3 different interfaces predefined: a source, a processor, and a sink. And you can combine and mix and match these in various different ways to cover a lot of different patterns. You can also create your own interfaces. All it takes is defining an interface with multiple subscribable channels, 1 or more, and 1 or more message channels, and Bob's your uncle, you're off and running. So, but I should ask this: who here is a Spring developer? A few, handful, okay. Spring's kind of philosophy. Okay, any people here from the old days who've used frameworks way back in the day? Okay, I'm the only old guy, that's fine. Most frameworks in the early days were literally there was one way to do anything, right? And it was the framework way, and if you fought the framework, you lost. That's frustrating to no end, right? So the Spring philosophy is kind of like an opinionated approach. Opinionated good, not bad. Because for 80 to 90% of use cases, we try to make it dead simple with the least amount of code possible to accomplish what you want to accomplish. However, if you still need to accomplish something that's a valid use case, but it falls in that other 10 to 20%, we want to make it pretty simple to do. You may just have to write a bit more code, a little more configuration or something, but we don't get in your way. We kind of actively get out of the way so you can accomplish what you need to do still. This is one of those opinionated approaches, right? So a sink, a source, processor, and a sink. A source is just the application, the thing that produces values, right? And then you have on the other end a sink, which is the end of the line. When it receives a message, it processes it, boom, you're done. That's the end of the line for that particular message. In between, you may have multiple processors. And these are your transformers. They'll take something, they'll manipulate it in some way, they'll pass it on. And again, you can chain these and fan out and things like that. So you have a lot of different ways to piece these together right out of the box. I'll show you that too. We'll code it. And I'm going to use Rabbit to tie it all together. Do what makes you happy. I just like Rabbit. Rabbit's super scalable. I think a lot of times we enter into this mindset that Kafka is the only thing that scales. Google and Pivotal put together just a test. And it was a couple of years ago now even, I think. And they said, hey, how far can we scale this out? Because Rabbit is built around clustering, right? So they were able to figure out that they could, I don't remember the exact numbers, but the total number of SMS messages plus iMessage plus WhatsApp in the US in a year, they could process in like an hour via Rabbit and scaled out on GCP, So it's not too bad on scalability. And it's got super flexibility in terms of routing. So that's why I kind of like it. So let's say you've done all that, right? We've just stayed imperative. We're just doing the normal stuff, but we're breaking out our application. We're teasing out the functionality. We're putting in messaging platforms. So we're implementing, we're decoupling. I should say as well that when you decouple, let's say that service A, service B, that producer and consumer of a message, you can scale independently too. Because you're not scaling service A and service B in lockstep. If service A is producing just a ton of messages, and service B, let's say it's just a sink, you have no processors. Your sink does a lot of processing on it and then end of line, but it's slower, right? If you need to scale that out independently of the producer, that's fine. 2, 5, 20, 100. So it gives you that independence in terms of scalability and decoupling as well. But once you've done all that, right, what then? If you hit the wall, how do you pass that? So at this point, we kind of back up and sidestep a bit. So I guess who here works in Java? Okay. The rest of you, just curious, what do you work with? .NET. .NET? Okay. What's that? .NET as well, okay. No PHP here? Oh, yeah. Okay, all right, that's cool. I'm not sure that what I'm going to be talking about next applies, but it's not a direct application, so just lay the parallels if you would. But in the Java world, typically, the way you scale traditionally has been for each additional connection, you spin up an additional thread, right? So you have an application that says, hey, here's another connection, here's another thread, and that works really well until you hit your thread pool limit. So when you hit n number of threads, it goes along pretty well. But when you hit n+1, what happens? that n+1th connection is going to wait. It's going to just be on hold, waiting for an available connection. What are the other, let's say 100, just to make it easy. So what are the other 100 threads doing at any given point in time? Typically nothing, right? They're blocking. They're waiting for a response from another service that they're calling, or a database call, or something like that. So what typically happens is you have a lot of threads that are tied up doing nothing. It's not terribly efficient, right? It is easier to reason about, right? 100 threads, oh, I've got another request coming in, or let's say 99 at 100th, life's good. But you quickly realize that there should be a better way to scale. Things like Node.js showed us that you can do some crazy scaling with a single thread. The problem is when you go to a single threaded environment, what happens when you have a bad actor? Everything stops, right? That's a bit problematic. Fortunately, it is 2019, and I think we are doing a better job of cross-pollinating and learning from other environments, as opposed to 5-10 years ago when nobody talked to anyone, and then just threw things at each other. So I think we're learning from each other, right? And at some point we realized that it would be really cool to restrict the number of threads, have a scheduler that kind of manages this, insert an event loop, and get some of that great scalability within the Java realm as well. Event loop adds a bit of overhead. So again, taking it back to that simplest example, if you have one connection, you can't get better performance than a single thread, a single imperative blocking connection. Because what happens is if I issue a request, I'm like, okay, I'm ready. As soon as you get the answer, give it back to me. Boom, got it. I mean, you can't beat that. So inserting an event loop adds a slight amount of overhead. But let's scale up to that n+1 number of threads, or n+100, or n+500. You start seeing that in a reactive model, you have a very flat performance profile. It doesn't slightly trail up like an imperative model, a blocking model, and then hockey stick, which is also nice. You have this nice flat, many more request serviced performance model as well. I'm kind of getting ahead of myself, but it kind of flows, I feel like, naturally. Reactive programming, again, asynchronous approach, event loop. It allows each service to go wider. There are also some performance gains in there, even though I don't typically talk about them a lot. But for instance, if you have a process that needs to run, and it has 4 different requests to 4 different backing services, and each one takes a minimum of a half a second, what's your minimum response time? No tricks. 2 seconds, right? If you can parallelize those and fire them off, and once the responses come back, reassemble and then send out the response, what's your minimum response time? Half a second. So you've got a potential 400% gain in performance. Now again, that depends on a lot of factors, your ability to parallelize what your service is doing and things like that. But it certainly is potential. It's certainly there, and you see that in certain use cases a lot, in certain use cases not at all. So I just point that out because I had de-emphasized it so long, and somebody's like, but can't you? Yes, you can. Don't count on that going in. Your use may vary. Okay, so let's see. Inter-project reactor. I kind of mentioned the first two. Project Reactor is an implementation of Reactive Streams, the Reactive Streams initiative. I will get into momentarily, but it certainly makes sense to when you're dealing with ways to scale, you deal with the interactions between services, because that and the communication are where most of the blocking, the waits occurs, right? And yeah, it'd be really great if you could actually find some integrations between that and your messaging platforms for optimal outcomes. So I like this quote by Rossen Stoyanchev, one of our Project Reactor team members. So much to his chagrin, I use it everywhere I go. My goal is to make him famous. But I really like the way that it summarizes everything in one sentence, even if it is a little bit information dense. And as Rossen said so well, in a nutshell, reactive programming is about non-blocking event-driven applications. Again, scaling with a small number of threads, and with backpressure as a key ingredient that aims to ensure producers do not overwhelm consumers. I want to point out a couple things out of that. For starters, small number of threads. I already mentioned why it was essential to have a small number, but it also makes sense to have a kind of an optimized number handled by a scheduler. And in most cases, we want the scheduler to do its optimal work for us, so we don't have to manually tweak that. But you still want the ability to, should you need to, right? For the foreseeable future, we're going to be dealing with certain, we're going to be interacting with systems that are still blocking. So it doesn't make sense to tie up a lot of threads with blocking requests, even as we're trying to scale our application, our services. So there are ways to create thread pools that are for blocking requests and separate those and partition those off as well, which again, kind of makes sense. Let's see. Back pressure. So far, I've talked a lot about concepts that has anybody done asynchronous programming here? Okay, they're the people who look sad, right? Is Dimitri in here? Dimitri is not in here. He said something hilarious the other day, which just killed me. It was just kind of a throwaway comment, because he's from Russia, right? And he said, you can always tell another Russian, because they have that look of despair in their eyes. I'm getting ready to go to Russia here in about a month, so I will see. But I'm getting kind of warm here, so I promise this is as much as I'll strip. Okay, nobody run out the back. But in an asynchronous model, you have a few problems. One is legibility, right? I mean, it gets really ugly after a point, typically. The term callback hell, anyone heard of that? I'm convinced that was coined by an optimist. It's really worse than that, especially if you have a very complex set of nested conditions. But the other thing that asynchronous programming in and of itself doesn't have is back pressure. Or not necessarily anyway. What happens if you have a slow consumer who is receiving values from a very fast producer? And I try to stay at that neutral terminology for a reason, so bear with me. If you have a slow consumer, typically it just falls over. It says, give me what you got. And then when the service B spins up and has a whole bunch of values to send, it just sends them, right? What happens to poor, slow service A? So with reactive programming, what you typically want, what you have is the ability for a slower service to say, look, I can't handle probably all you're going to send me. Just send me 10. I can process 10 at a time, or 100, or whatever. And once I get done, I'll request more. Doesn't change the fact you have a fast producer and a slow consumer. What it does do is shift the control to your producing service. Typically, we may not have control over an iPhone client 2 provinces over, or 2 countries over, right? But we do have control over our cloud service. So if we're producing a lot of values and that particular that client isn't able to handle them, we can determine what to do. Now maybe we want to sample. Maybe we want to buffer a certain amount. Maybe it's like a dashboard and we only care about the now. We don't care about the status 3 months ago or 3 minutes ago. We care about now, so we can just drop the intervening values. But we have that control. The control is back in our hands as our producing service. So again, shifts the dynamic to where it gives us as developers more control. Let's see, what else? So Reactive Streams-based microservices allow you to extract more work from fewer resources, keep the threads that are alive hot at all times, and therefore kind of scale wider, which again, maintaining that performance profile that's so nice. Okay, Reactive Streams, very simple concept. The Reactive Streams initiative was created by several companies, organizations coming together and saying, look, we recognize this is a problem. Rather than solving this all in incompatible ways, let's do something together and work out at a basic level what we can agree on. The Reactive Streams initiative was the outcome. So companies like Twitter, Kazing, Lightbend, Red Hat, Pivotal. Seems like there's always 1 or 2 I forget. It's probably good. But you, as a result of the work in the Reactive Streams initiative, you have Java 9's Java Util Concurrent Flow, Java 9 Plus, okay? But this is it. The Reactive Streams initiative had 4 things: the textual spec, which kind of explained it, right? The API and the TCK, so you can verify how compliant you are, where you fall short, what you need to fix, and then examples for how to implement it if you're an implementer. So this is the API. 4 interfaces, that's it. So it's very granular, right? You have a publisher, which is the thing that produces values. You have a subscriber, which is the thing that consumes values. You have a subscription, which is the contract entered into between subscriber and publisher. And then you have the processor, which incorporates both subscriber and publisher because it'll receive values, manipulate them, pass them on, right, to its subscribers. So it's very granular and it's very simple. It's a very useful foundation. But in order to use this, remember, there are 4 interfaces. You're going to have to provide an implementation. So you can either write one or use one. And there are several good ones out there, like RxJava, Akka Streams, Project Reactor. We shepherd Reactor, but there's a lot of cross-pollination across the different projects, so we all get along pretty well. But everybody has a different take on what the implementation should be, right? And as long as they're validated and compliant, we know they all work, they interoperate. But Reactor's been picked up by like Google and Microsoft and Facebook and tiny companies like that as being the kind of preferred mechanism. So yeah, we're kind of fond of it. I will say this, that if you're a Spring developer, it's very simple to switch over to a reactive model, fully reactive model, so you can bring your knowledge with you versus throwing it away at the door and having to relearn everything you've ever known, which I find extremely useful, especially when you're having to context switch in the middle of a day when your boss says, hey, the new system is having problems or the old system is. It helps with that quite a lot. But from our perspective, we took the idea of a publisher. In imperative Java, let's say you have a return value from a method. You can return an object of type T, for instance, or an iterable of objects of type T, a collection. And the same thing kind of goes in our minds when you go to a reactive model. You can return a mono, 0 or 1. You know, you're at most going to get one value. And it'll return it when it's ready, when it's available. You can also have a flux, which is what a 0 to n, right? It can be a small collection. It can be an indefinite number of values over an indeterminate amount of time. But you'll have operations that'll apply equally well to both fluxes and monos, some that won't, right? Some kind of make sense when you're only dealing with one object. Some make sense when you're dealing with a collection of objects. So if you hear me say flux or mono, and you will, then you'll know where I'm kind of coming from with that. Okay, so in context, we talked about messaging platforms. We talked about reactive streams. Wouldn't it be cool if they kind of work together? Well, the good news is there's a lot of symmetry between the two and synergies. So you have the parallel, that's terrible with the blue in this lighting. It says Spring Cloud Stream parallel. So for a publisher, a reactive stream publisher, it corresponds with the source. It's the thing that produces values, right? Your sync corresponds with in Spring Cloud Stream, corresponds with the subscriber. It's the thing that gets the values. The gazentas and gazautas, right? This is the thing that gets the values. The subscription is, the function of the subscription is kind of fulfilled by the pipeline itself, RabbitMQ, Kafka, et cetera. And a processor is like a processor, right? It takes a value, transforms it, and passes it on. So we can see that the concepts are very complementary. And that makes life a lot easier, right? Okay, so with that, let's code. Wow, anybody know who this guy is? Does anyone recognize him? Okay, good, a handful. The rest of you, it's Saturday, that's the good news. Tomorrow's Sunday. I'm gonna give you some homework. It's the good kind though, right? If you haven't watched the IT Crowd, it's on Netflix still, right? Okay, good. Watch the IT Crowd. It's a Britcom from, gosh, what now, 5, 7, 8 years ago now? More? Time flies, yeah. It's a little dated, right? Going back and looking, I mean, they still have the CRTs, if I remember right. But it hits really close to home in many cases. So you'll laugh, you'll cry. It's just great. They did 2 seasons of it. 2 seasons, or a series, as the Brits called them. And they were wildly popular. But they wrapped up and just stopped, and they didn't kind of put a neat ending on it. So a couple years later, who was it, BBC, I think, who went back and said, hey, how would you like to do the send-off, like a 2-hour special? And the writer said, well, let me see who I can get to come back. Everybody came back, every actor. So it was really, really, I mean, I think it's a testimony to how well the show was received, how cool the show was. Get it, watch it, just binge it. Watch it tomorrow, it's good. All right, so we're gonna go with that. That was Moss, by the way, Maurice Moss. He's one of the protagonists in the IT Crowd. So yeah, I'll leave it at that. Okay, so I'm gonna switch this back to where we can all see, mirrored. And let's see, so, okay. So this is the Spring Initializer. This is where we're going to start to create Spring Boot-based microservices. You don't have to use this. You can create them all by hand. Not the most productive use of your time, but you can certainly do it. You can also curl or HTTP this endpoint. You can also usually access it from from any major IDE. But I like to go here because it just makes me happy. It's a nice, easy to use interface. and you get access to the latest, greatest when they update it. So we have a team specifically who maintains this. And by the way, this is open source too. So if you really like this, but your company's like, oh, I don't want you to have access to all those libraries, which always makes me a little sad, but some companies do that stuff. You can fork it. You don't even have to fork it now. You can actually tweak it, your configuration, and run it internally and just have your own stuff. So again, even that's open source. There is a dark mode and a light mode. I typically go dark mode, but just for readability, we'll stay with that today. I got pulling out all the stops for visibility because it's kind of bright. So we'll go here, and even here you have options, right? So if you're a Maven developer, you can generate a Maven project, Maven-based project. If you're a hipster, you can generate a Gradle project. So it's up to you. For some reason, I always go with Gradle when I do Kotlin. I always go with Maven when I do Java, but do what makes you happy. We support Java, Kotlin, Groovy. We'll use current version of Spring Boot 2.1.8. I'm going to change the project metadata to the hecklers. If I can change this. Can't type. This is going to be bad. I always tell the front row, really appreciate you sitting up here because I type fast and I also typo fast. So if you spot a typo before I hit build, yay, good on you. If you don't, it's all on you too. So, because you're close, you can see this stuff. Okay, so I'm going to just create one of each, right? A source, a processor, and a sink, again, as a foundation, a jumping off point. And we can choose our dependencies. And with Spring Boot, it has three big things that are awesome, right? It has auto configuration, which allows you to, it checks your code, your annotations, your class path, and says, hey, look, you have a database driver in your class path, you've extended an interface defined in Spring Data, I bet you want to talk to a database. It's not really a great logical leap, but it helps make your life simpler, right? You can focus on the business problem at hand. Can you override it? Sure, you can turn all that off. But again, in many cases, it just makes you more productive. So we start from the point of productivity and tweak where you need to. Auto configuration. Then you have simplified dependency management, because instead of saying, I've got these 38 dependencies, you're like, I want to provide this capability, this capability, this capability, and each of those capabilities, right? You bring in this library, it requires this library, and this library, and this library. But if you nest those, and you have starter POMs, you're able to simplify that and reduce the crazy build file that you have to a more manageable looking one. Again, you can inspect, you can exclude, you can override, it's fine. But in most cases, you don't have to because all the dependencies are battle tested together. Version synchronized too, which makes life nice. And the other is simplified deployment, right, with an Uber jar. And of course, you can split that out too. But in most cases, it's a very, very helpful thing. So I'm going to pull in a few dependencies, reactive web, and that gets us Spring Web Flux, based on the name Flux, but it's our project reactor bits, so we can deal with things reactively, right? We get all the good stuff. Those of you who are used to Spring MVC know that Tomcat is the default servlet engine. You can use any servlet 3.1 compatible engine to get the asynchronicity to handle reactive deployment, but Netty is by default, hands down, the best, most proven. That's what we default to when we use Spring Web Flux. I'm also going to bring in the dependency for Spring Cloud Stream, Reactive Cloud Stream, and as you see, it says here, again, for auto configuration, we know that we're going to be dealing with a messaging platform, but we need to include a binder so it knows what messaging platform to bind to. So it suggests like Apache, Kafka, RabbitMQ, for example. I'm going to use Rabbit today, so Spring for Rabbit. And then I'm going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad. Lombok allows you to eliminate a lot of boilerplate. If you're writing Kotlin, don't worry about it. You'll never use Lombok. If you're writing Java, you might want to take a look at it. I don't use it in production typically, but it works really well in demos because it allows me to focus again on the code that matters. And we'll generate that project. I'm going to save this out to the desktop. And since, I know we're doing okay on time, but just to try to maximize our time, I'm going to go ahead and create each of our projects here in one go. Sync, and then we'll go here and we'll open that. Wow, that worked well. Okay, so let's see. Boom. There we go. And I'm going to open that in my favorite IDE, NetBeans. Ha, kidding. Any NetBeans users here? I like NetBeans. It is an awesome IDE. It really does have great Spring Boot support. If you're using NetBeans, keep using it. It's great. I only pick on my friends, right? Anyone use Eclipse? Eclipse is also a great. Eclipse is also an IDE, right? I've used Eclipse at various different client sites and projects over the years, and I always liken it to the, you've seen the thing, the meme or whatever, the funny photo of the Swiss Army knife with like 300 blades. That's Eclipse with its plugins, right? I mean, you can do everything with Eclipse. It's just finding the right blade. So I'm not a huge fan, but I will say this. We have a build of Eclipse called Spring Tool Suite that has cloud deployment capabilities that are just hands down awesome. Every time I see the latest updates to them, I kind of cry because they're good. I use IntelliJ as somebody who uses Kotlin a lot. The folks who are behind the development of Kotlin are also the creators of IntelliJ. So as you might imagine, there's great interactions and integrations between the two. But use what makes you happy. Just don't use Emacs. Please have a little self-respect. So I'm going to go to my application properties with, I need to blow this up. Wow, that's terrible. So let's see, font. So I'm going to go to here, and I'll go to my Ambiguous font, and we'll see if that shows up here. So server.port. Wow, that kind of washes out. Can we turn off lights? I don't think it works in light view, in light mode. I find that the light view washes out even worse than, I go to high contrast for presentations because this is just a door thing. Oh, that's disappointing. Oh yeah, how do you do that?
Good question.
Yeah.
Alexa, close the
Yeah, really? Here we go. Close. Close. No, that. Wow, that works well. Okay, so let's see. Open. Close. Down. Yeah, there you go. What?
You just got to do one at a time.
Oh no, that's not going to work. Well, it was worth asking, I guess. So I wonder if I hit this button, what happens? Oh, that got darker, right? Oh, there we go. As long as it doesn't shut off the projector. Okay. I can switch to light mode. Let's try it, I guess. I find that it washes out so badly that usually it doesn't. So let's see. Color scheme. No, actually. Oh, yeah, actually. Color scheme. There we go. Let's try that. Yes. Oh, my eyes. And why did it shrink? This is my Ambiguous font setting. Why is it so small? Wow, that's terrible. Okay, so let's go back here. Color scheme font. Oh, default. There we go. Ambiguous. That actually is better. I've had both ways, but a lot of times if the lighting is a little weird, you go white, you don't see anything. So let's run with this. Okay, so for each Spring Boot application / microservice you're creating, you can assign a server port if you want it to start on a specific port. Again, there are defaults. It starts up on 8080 by default. But if you want it to start on a particular port, you can put it here. If you set this equal to 0, what happens is upon initialization, the application will go, give me a random free port. I'll use that. And that way, if I'm scaling out here locally, I don't have to worry about port conflicts, which is always a good thing. How am I doing? We're good. Okay. So I'm going to define just a couple properties. So I've got my Spring Cloud Stream. Wow, that's weird on the background. This could be fun. So I'm going to set up my bindings for my binder. This is my source, right? So a source has an output channel. It's the thing that produces values. Kind of makes sense. It just has an output channel. So I'm going to define my output channel as having a destination of processor. And you can call this anything you want. This is just our pipeline. I stay, again, at that abstract level of terminology because if you're dealing with Kafka, you're probably thinking in your head, you're translating to topics. If you're dealing with Rabbit, you're probably thinking exchanges and queues. What happens when I get talking fast is I mix and match, which is terrible. Everybody is confused then. So I just stay at the pipelines level. Please do the translation for your particular platform if you're using one already. But we're going to call this our processor pipeline. And then I'm going to set up my function definition. We'll come back to this momentarily, but this is how Spring Cloud Streams API is evolving to deal with reactive streams and to integrate to provide the integration between the Reactive Streams API and our applications with messaging pipelines, messaging platforms. So I'm going to go here to my application and we'll start coding. Now, life advice. Do what you love, right? That's what they always tell you to do. And I love coffee, so most of my talks I do examples about coffee. But once in a while I have multiple talks in the same conference and it's like, I've got to come up with another example. What do I love? Well, coffee. Okay, well, what do I know? What else do I know? And those of you who know me, who follow me on Twitter, MKHeck, by the way, those of you who don't, why? Why not? Please do. I talk about fun stuff. I retweeted that it's Batman Day. Did anyone know that? See, you need to follow me. Anyway, this is vital stuff. But getting back to the tech stuff, the boring tech stuff. So one thing that I do a lot of is I travel, right? I'm a developer and advocate, but I spend a lot of time in various different times of the year gone, just gone. My home, I pay taxes on a house in St. Louis, Missouri, center of the US. I visit it once every so often to maintain residency, and then otherwise I'm often flying different places. I came here from San Fran. I'm going to Madrid after this. So I know a little bit about flying, right? About the travel experience and how terrible it is. And I thought, wouldn't it be cool if we wrote a series of applications to bring that in line, right? To help the poor folks who have to stuff themselves into overhead bins. And yes, I'm speaking from experience. So I thought, why not? Let's do this. So I'm going to create a class. We'll start with our domain, and I'm going to create a class called passenger. Passenger. I saved you, front row. I caught the typo right off. So we're going to keep this, again, fairly simple. I'm going to just create some very simple member variables like ID and name. That'll be sufficient for our purposes. Typing is hard. This is a weird angle, and I've got my roost so I can get this higher, but then I'm typing like this, so it should be fun. I'm going to use @value. This is a Lombok annotation. Lombok has an @data annotation, which makes it a data class, gives you getters, setters, equals, hash code, two-string methods by default out of the box. Then you have your @allargs constructor, which gives you a constructor with arguments, one argument each for each of your member variables. You have a no-args constructor annotation, a required args constructor annotation, all that. But @value combines @data and @allargs constructor out of the bat. So you have a data class, right? An immutable-ish data class. I say ish because, as a friend of mine once said, nothing is truly immutable if you're sufficiently motivated. But we'll call it immutable for now. So here's our passenger, right? This is a source. It's going to produce values to push into the pipeline. We can do that manually, or we can be lazy again. I'm lazy, so I'm going to create a component to do that for us. This will be our passenger generator, spelling is hard, and I'm going to create a couple things in here, right? I'm going to, let's see, we're going to create a list of strings. There we go. And we'll call this our names, because these are the names we'll draw from for our passengers. Arrays, as list, and we need some names. What's your name, sir? Mark? I'm sorry.
With a C.
Oh, with a C, that'll work, because I've got to get me in there for the specific punishment that airlines always deal out. I use me as the worst example. I don't feel like it's fair to put anyone else through that. Okay, you, sir.
Bain.
What is it?
Bain.
Spelling, please.
B-A-N-E.
Oh, wow. Oh, my goodness, that's Bane. That's scary. So are you stepping over here now? Okay. Your name? Tim. Okay, can you spell that? Just kidding. Your name, ma'am? Charlene. Is C? C-H-A-R-L-E-N-E? Oh, lucky guess. As with most names, there are variations. Even Mark, I always kind of joke that I let people off way too easy, but there are variations. M-A-R-C, M-A-R-C-K, so on and so forth. Okay, what's your name, sir?
Dave.
Dave. Okay, Dave, that's interesting, because when people forget my name, they call me Dave. So, Dave? Yes? Yes? You? What's your name? Uh-huh.
Yeah, I don't know who you're looking at.
I'm giving her a hard time because I know her. That said, I honestly don't know how you spell Sandra. So, okay, well that was one of my two guesses, but again, slight variation. So okay, so let's see, you, sir. Guillermo. I know how to spell that. That's ironically, that's easy, unless you have a weird spelling on it. And then let's see, Guillermo. See? Excelente. Okay. All right. So we'll stop there because that's actually I need to again add me because we've got to have somebody to use as a bad example. All right. So that's our list of names. So I'm also going to inject a bit of randomness because random's fun, right? So new random. And I'm going to close that out so we have a little more room. So that gets us our generator. So we will generate. I still am squatting down here. You probably haven't noticed that I'm not overly tall, right? And yet still sometimes just the angle and the situation is kind of rough. So I'm going to generate a passenger and return new passenger. We'll use UUID, random, toString, and that gets our ID. And then we'll take from our names, we'll do a get. We'll use our random next int, and we'll bound that based on our names dot size. Perfect. Oh, there we go. Okay, so that will generate our names, right? Or generate our passengers. So now what I need to do is push them into the pipeline. So we will enable binding, and we'll bind to our source class, and this will be our, let's see, this is our desk agent. So this was what happens when we buy a ticket. We're not really a passenger until we check in. So we can check in on our phone and our laptop, whatever, or we can go to the desk agent and say, I'm here. Here's my passport, so on and so forth. So here's our desk agent. So let's see, I need to inject a few things. Oops, that was way off target. And I'm going to inject my passenger generator. So let's see. Now, with Spring, you can do field injection, which is evil. It's not testable. You're assuming you're creating something. You're assuming something will be there that may not be there. Or you can do constructor injection, which is the right path, right? So we can create a constructor, or again, lazy, I'm going to use Lombok because I'm already using Lombok anyway, and ask Lombok to create a constructor with all arguments, one argument for each member variable, which we have one. There it is. So now I'm going to create a bean, and this bean, this is the new API, the evolving API of Spring Cloud Stream. So if you notice a source, while also working along the same lines as a publisher, right? It sounds a lot like a supplier in Java. And a sink sounds a lot like a consumer, right? It just consumes something. And a transformer, a processor, sounds a lot like a function that takes one kind of value and produces another kind of value. So this is a very simple composable API. Why not use it? So we're going to create here a supplier, and we're going to, instead of just supplying a passenger, right? We're going to supply a flux of passengers. And this is a reactive stream of passengers that we're supplying. So we'll call this check-in. Clever, right? So a supplier is a functional interface with a single abstract method. And since Java 8, what can you do when you have a functional interface with a single abstract method? You can provide a lambda for the implementation, right, of that method. So this is what we're going to do. We're going to return flux. Actually, we need to create our flux, right? Flux dot. And we're going to create a flux that will produce values over an interval. Words are hard. And I'm going to have it produce a value every second. And then I'm going to just take that long value and I'm going to map it to a new passenger. I'm going to use my generator to generate that for us. And that should be sufficient, except, again, better practices. When you have a flux, when you have a publisher, you should define what happens on back pressure. So you have different options. And now, assuming 1 per second is probably not going to kill any consumers, but just in case, right? It's a good practice. So on back pressure, you can set up a buffer. You can define the size of the buffer, what have you. In this case, we'll just drop the intervening values because dashboard, we don't care. But this allows us to get up and running pretty quickly and pretty easily. So that's our source. Let's go ahead and create our processor and our sink, and then we'll wire them together. And then we'll talk about some other stuff. It gets more fun as you build. Okay. So let's open our application properties. Once again, we have server port 0, Spring Cloud Stream. Let's see. Oh, I did forget to do one thing. Go back here. Because I have my check-in supplier, right? And close. So we need to add that as our function definition. So that's our bean, right? That is our supplier. That becomes very important here shortly. So here, we go back over to our processor, we have our bindings. A processor has an input channel and an output channel, right? It's a processor. So for our input, we're going to be drawing from the destination of processor, as we called the pipeline earlier from our source. I'm also going to add a group setting. The reason being, if you create multiple consumers of a particular messaging pipeline, again, trying hard to stay above that the terms, but if you create multiple consumers and they're in separate groups, everybody gets a copy of the same message, which is great if you need to implement a fan-out pattern. That's exactly what that is. But if you need to scale, you want them all in the same group so they can take turns processing messages. So if you have 2 consumers, it's roughly 2 times the number of messages they can process. 10 times. If you have 100 consumers, they can process roughly 100 times the number of messages out of the pipeline. So we're going to put them in the same group if we scale, if we have time. Probably not at this point. And then for our output channel, destination, we'll just point this to sync. We have a Spring Cloud Stream bindings. Oops. Function definition, and we'll come back to that. And somehow I'm running short on time, so we're going to fly through this a little bit faster than I intended. So I'm going to create my class passenger, private final string ID and name, and then we're going to transform a passenger. Once the passenger gets from the desk agent, they go through security, they go to the gate. They're now a flying passenger, right? So at value, once again, class flying passenger. And a flying passenger still has an ID and a name, right? Kind of makes sense. But a flying passenger, as an airline, we want to be able to recognize passengers and surprise and delight them, right? So we're going to create an enum, in an ideal world, of course. So we're going to create an enum, and all passengers are valued. Okay, work with me. All passengers should be valued. But once in a while, some percentage of the time, we want to declare a passenger a premium passenger and maybe greet them. Bring them to the front of the plane for a change. Give them an extra package of pretzels, dry pretzels, whatever. But we want to recognize them as being premium customers. Give them a little extra attention if we can. And then we're going to enable binding. We're going to make this a processor once again. And this will be our class. This is our gate agent. Gate agent. And let's see. So at bean, and this will be a function, right? So we'll transform a flux. Again, we're dealing with reactive streams, so we're not dealing with each individual value, we're dealing with streams of values in this case. So we're taking a flux of passenger, and we're going to convert that to a flux of flying passengers, and we'll call this greet passenger. Okay, so return, right? So this is, we're taking a flux, and we will take the flux and we will map the value for a passenger to a new flying passenger. We'll use the passenger's ID, we'll use the passenger's name, and I just realized I want to add a little randomness to this as well. So we will create a random, random, RND equals new random once again, and then we'll grab the passenger's name, and we will do random.nextInt, nextInt. So let's see, if nextInt 5, so we'll out of every 5 times, we'll bump this up, we'll make it out of every 4 times. If it equals 0, right, we will say that they're a premium customer. Premium. Wow, come on. Status, premium. There we go. Otherwise, they're still a valued passenger, right? Well, in an ideal world. So they're still valued, and that's fine. So, and why did that do that? So let's see. There we go. Let's see. So,
Missing a variable for status.
what am I missing?
A variable for keeping your status in your flying passenger. Or field, I guess.
Oh, yes. Actually, I skipped. Actually, that should be, get name, right? And the status, yeah, so I'm assigning a status here. Flying passenger.
Missing the status field in flying passenger.
What?
Missing the status field in flying passenger.
Oh, it's there. Oh, thank you very much. Yeah, I was trying to speed this up, and inevitably when you do that, something falls on the floor. So status. That seems much happier. Okay, so we've got our processor. We'll take this greet passenger, and we'll move that here. That's our definition. Save that. We'll go back over here, and we'll open up our sync. Open. And hello, IntelliJ. Come on. There we go. Nice. Sort of nice. Okay, application properties, server.port 0, Spring Cloud Stream, function definition. The bindings, in this case of a sync, it has an input channel. Destination, in this case, is sync. That's what we called it. We changed this to group as well. We bring in the same name for the group. And then for a Spring Cloud Stream function definition, we'll come back to that, and we'll go here. In this case, we're transforming from passengers to flying passengers in our processor. So we will make a class here for flying passenger, because that's, again, all we should be receiving at this point from our consumer, our sync. So private final string, ID, and name. And then, of course, we have enum status, valued premium, right? And then private final status. Perfect. Okay, so now, thank you. And enable binding, in this case to our sync class, and this will be our flight attendant. This is where it really gets fun, right? So flight attendant. And let's see, here's our bean. This will be a consumer. We're going to consume a flux of flying passenger. Come on, there we go. Sweet. And we'll just, let's say welcome passenger. So welcome passenger. And we'll just log this. So we take our flux, and we do a flux.subscribe, and we just log this. So we can take a look here. Print line. Okay, so let's go ahead and restart this. One other thing here. That's important. So let's restart this now. That'll be happier. Okay, so we know this will work. Nothing ever goes wrong in live demos. So I'm going to go ahead and restart my processor. Yeah, well, you know. And here's our source. So we're going to kick that off, and we're going to trust that everything will connect and work just fine. So we're connected. Look at that. Okay, so here's our sync. Once every so often, we get a premium customer, but most of them are coming through as valued, as we would expect. Now, as you might imagine, I need to show you something else which is really cool with the new API, which gives you a lot more flexibility and composability. In the old days of Spring Cloud Stream, and in the current non-evolved, API, you typically had a transformation method you would create, which had a lot of stuff in it, right? It makes a lot of sense to make those more composable. And I'll show you what I mean by that here in just a moment. So I'm going to stop my source. So when I was looking at the problem of airlines, I thought, I fly a lot, and I'm mistreated a lot. There should be some way I can fix this, especially if I'm writing the system to replace their other system. So I thought, let's see what we can do. So let's go into our processor. And we're getting a flux of flying passengers out of here, but let's create another bean, right? Let's not typo here, another bean. Kill caps lock. So I'm going to create this as a function, taking a flux of flying passengers and returning a flux of flying passengers, and treat mark. And I thought this seemed like a really good idea when I started off with this, right? I mean, what could possibly go wrong? So I was thinking, how could we make this better? So we need another status here, right? Something along the lines of guaranteed, with spelling. Spelling is hard. Guaranteed upgrade. And I'm thinking, that's looking pretty good. But then reality hit. And I'm thinking, there's no way this will ever get through audit. So this is really what the final result was after multiple code reviews and passing into production. The guaranteed upgrade became enhanced screening seat by toilets. This is my life. Okay, so I'm just modeling reality here, folks. So I'm going to, in this case, we're going to return a flux. This is our lambda once again. So flux.map, I'm going to take my passenger, let's shorten this, passenger. We'll do a new flying passenger. We'll take our passenger's ID, that's great, our passenger's name, and if the passenger's name, get name, equals ignore case mark with a K, right? It's all good. If that's the case, right, then we're going to, what really happens is we're going to get this, right? Otherwise, we'll just bring in the current status. So status, actually I should just do passenger.getStatus. So that's really what happens. And then of course, we have multiple transformations potentially happening. So we're going to pipe these, just like at the command line. Now this is really cool because you can dynamically change this with environment variables too. So this is super dynamic, gives you a lot of flexibility. And again, out of the box, if you're in one of those environments where things can rapidly change, need to change for a valid business reason, or just because you have a terrible boss, this gives you the power to do that. So let's go back here. Apparently nobody has a terrible boss, which is good. So that's good. Let's restart this, the source, and then we'll see what comes out the other end. And then we'll stop, because I'm 5 minutes over already. So we see here that we're getting, let's see, did it stop? There we go. Yeah, there we go. Oh gosh, thank you. I completely forgot about our sync, didn't I? So we're going to go to our sync. I have to add that, and I'm going to cheat here. Just, oh, yeah, there it was, because it's easier to copy paste in this case. No. There we go. Yes, all right, so now let's restart this, and this will be much happier, and I'll be much sadder. Oh, and here we go. Okay, so as you can see, everybody is treated at least as badly as they were before, not any worse, except for me, and there I am, right there, every time I fly. Okay, so we're going to stop there before anybody gets too depressed, especially me. And we'll wrap up with our slides here. So if you'd like to play with this, kind of get started, here's the best resource, at least again from the starting point, Building Reactive Pipelines repo out under my GitHub account. And of course, if you want to know more about Spring Cloud Stream in general, some of the capabilities it gives you out of the box, as well as the extensibility, it's out on the Spring Cloud Stream project page. From there, of course, you can follow the link there to get to the GitHub repo and see it all. Again, 100% open source from day one. Project Reactor project page, also a great documentation, if I do say so myself. If you want to reach out to me, email works. Twitter is better. I live on Twitter, MKHeck. And thanks for coming, and have a great last session of Voxays Banff.